Everyone's still talking about large language models, but a silent revolution has already begun. And it is not what you think. 3 out of 4 AI scientists say LLMs will never reach true intelligence. And the architect behind Meta's AI now calls them a dead end. What if the future of AI is leaving LLMs behind and moving towards something more powerful, autonomous, and unpredictable? The stakes are higher than anyone admits, and the real question is, are we even looking in the right place? Pattern recognition has taken large language models to impressive heights, but the cracks are showing. These systems excel at mimicking language, yet they struggle to remember earlier conversations and to understand the world beyond their training data. When asked to solve problems that require real reasoning, they often fall back on surface-level guesses and miss the underlying logic. As researchers pushed for bigger and bigger models, the costs soared. Training a cutting-edge model now demands energy on par with a small town, and each new leap delivers less progress than the last. Scaling up does not solve the core problem. Large language models predict what sounds right, not what is actually true. Without genuine memory, grounding, or self-correction, the limits become impossible to ignore. The field is reaching a point where more power and more data just cannot buy real understanding, and that is forcing even the biggest believers to reconsider what comes next. Yann LeCun, one of the most influential thinkers in artificial intelligence, is not buying the hype around large language models. In 2025, he called large language models a dead end for building true intelligence. Those words cut deep across the research community. LeCun's words hit a nerve. When a survey of 475 scientists found that 3 out of 4 agreed, the message was clear. Large language models alone will not reach human-level reasoning. That is not a minority opinion. It is a warning shot from inside the field. LeCun's exit from Meta in 2025 made headlines. He left to pursue artificial intelligence systems that could actually model the world, not just predict the next word. The point was stark. Chasing ever larger models comes at a steep cost, and the smartest minds are searching for something fundamentally different. The stakes are not just technical, they are personal, as leaders like LeCun step away from the biggest platforms to chase a new vision. The question the whole community is asking now is simple. Are large language models only the beginning? A new generation of AI is stepping beyond pattern matching and into something closer to independent thought. Instead of just predicting the next word, these systems build internal models of the world, like running a flight simulator in their mind before making a move. This approach lets them plan, adapt, and even anticipate the consequences of their actions. In the enterprise world, agents are already making waves. They are not just answering emails or scheduling meetings, they are breaking down complex goals using APIs and learning from feedback to get better with every task. Companies poured $750 million into agent platforms in 2025 alone, a 10-fold jump in just a year. The promise is clear: agents that can reason, remember, and act, not just react. These world models and autonomous agents are designed to fill the gaps LLMs cannot, giving AI the tools to understand context, simulate outcomes, and operate with a level of autonomy that was out of reach just a few years ago. Hybrid artificial intelligence systems are quietly rewriting the rules of intelligence. Instead of relying on brute force, these models combine neural networks with structured logic, weaving together intuition and step-by-step reasoning. In practice, that means a system can spot patterns in data, then apply symbolic rules to check its own work, catching errors and refine answers in real time. This approach is not just smarter, it is far more efficient. While traditional large language models burn through massive amounts of energy for every task, hybrid systems use targeted bursts of computing power only when a problem calls for deeper thought. One breakthrough is test-time computing. Rather than front-loading all the training, these models allocate more resources when they actually need to reason, much like a person taking extra time on a tough exam question. The result is a toolkit where large language models are no longer the centerpiece. They are one ingredient absorbed into systems that deliberate, verify, and adapt on the fly. For the first time, artificial intelligence can weigh options, simulate outcomes, and choose the best path, all without the waste of endless scaling. Devin, the much-hyped autonomous coding agent, stunned the tech world when it solved a live Notion-to-Sheets data pull in a matter of hours. It was a breakthrough that had engineers celebrating, but the excitement faded fast. In independent audits, Devin succeeded on just 15% of complex tasks, stumbling into endless loops, inventing fake API calls, and burning through days of compute with nothing to show but confusion. Even simple projects sometimes dragged on for days until a human stepped in to break the cycle. Meanwhile, aboard the International Space Station, NASA's Simon robot managed to command other bots, freeing up crew time. Full autonomy remained out of reach. Safety protocols kept humans in the loop. These stories reveal a pattern. Agents can dazzle, but when left unchecked, the consequences can spiral. For every breakthrough, there is a reminder that reliability still lags far behind the promise. Revenue from AI platforms crossed the billion-dollar mark for at least 10 products in 2025, with another 50 clearing $100 million in annual recurring revenue. But the boom came at a price. Cloud providers reported power use doubling, or even tripling, as next-gen agents hit the market. Internal audits flagged data centers drawing more than a gigawatt, rivaling the needs of entire cities. Meanwhile, industry groups poured millions into lobbying, urging lawmakers to favor goal-directed AI agents in new policy drafts. That phrase is now woven into both the EU AI Act and US Senate proposals. The stakes are no longer confined to code or research papers. They are rippling out through the grid and into the halls of government. The race to smarter and more adaptable. AI is already reshaping research labs worldwide. As new systems blur the line between tool and agent, the real revolution begins. We are only just starting to understand.